We're going to show you how to locate the embedded right triangle inside of your ellipse. Now, my presentation is labeled differently than the presentation in figure 7.18 on page 540 of your textbook. That is Długopolski College Algebra 6th edition. But I think it works better. Now, if you prefer going with the text, fine, but this is my presentation and I label everything according to these pictures. So we have first the stretched ellipse in the horizontal direction, so it has a horizontal major axis, and then we have the next example, the vertical major axis, where the ellipse is stretched in the vertical direction. Now I want to label the sides. First of all, the side up and down from the center, which I place in the origin for this example, to the upper edge, that is this distance. And that is called the distance, I call it the distance B. I call it the same distance in the vertical example. So this distance from the center up to the top edge is called the distance B. I think it's just easier to remember. It's the distance up, and it's also the distance down from the center in both of the examples, the horizontal and the vertical. Now, the other distance of importance is the distance from the center out to the right and left edge. So this one, that is what I label distance A. And I do the same label in the other example, from the center out to the right and left side is a distance A. So we're only drawing one version, but you understand it's happening on the other side as well. Okay, now where is the vertex located in each of these examples? The vertex will be situated at the edge, each edge, there are two of them, on each edge of the major axis. So the vertex is out here, but for this one, it's up here at the top. Let me circle it. Vertex, and there's another one, of course, on the other side. And then vertex, and there's another one down below here. Okay, but that distance is, so you can see the distance from the center in the horizontal major axis example on the left. The distance from the center out to the vertex is called A. But in the vertical major axis example, that distance from the center up to the vertex is called B, because I always label the vertical distances B and the horizontal distances A. Now, the right triangle is formed by locating another important point, and that is called the focus. The focus in the first example, the horizontal major axis, is located on the major axis, but it's not as far out from the center as the actual vertex. So it's maybe approximately here, depending on the shape, exact shape. That is our focus. I'll label it F. I'll go ahead and circle it. And of course, there's going to be an F, a focus on the other side. We have two of them again. Now, on the other example, the focus is again on the major axis, but it's from the center out, not beyond to the vertex, but a little bit short of that. So it's approximately located here. That's my focus. I'll put a circle around it, and of course there's another focus down below before you get to the vertex. Okay, now we're ready to draw our right triangle. This is going to be the right angle, the 90-degree angle in both cases. And what it does, looking at the first example, the horizontal major axis, the edge of the right triangle, actually the edge opposite the 90-degree angle, it is located in such a way that it connects the focus to the edge of the ellipse. So we go down here, and there is our hypotenuse. And that distance going from the edge to the top, it has not been labeled yet. We will label it later. And we have a similar situation where the focus is connected to the edge of the ellipse. There we go. So now we formed our right triangle. Let's actually bring it out of its embedding and look at it closely here. Here's our first example. And we know the distance B on this side. And we know the distance. Well, actually, we don't know the distance on the bottom, because see where it terminates here at the edge at the point called the focus. All right, and we haven't labeled in the graph above, we haven't labeled the distance from the center. The center is over here. That's HK. We haven't labeled the distance from the center, HK, out to the focus yet. Okay, let's draw the other one. It's tall. Here's our right angle. Here's our center, HK. And the distance out to this edge, we know. That is, from the picture, labeled A. Where's the focus located here? It's located at the top. Okay, so we only have one side located in each of these cases. Now let's work further on this and label the rest of the sides. Well, it turns out that that distance A in the first example, which we see in the upper graph goes from the center out to the vertex, that turns out to be the same distance A of the hypotenuse. And similarly, the distance of the hypotenuse here is going to be the distance B. See, in the original picture on the right, B is the distance from the center, HK, let me label HK here, up to the top edge, where the vertex is located, of the vertical major axis. But that's the same distance B of the hypotenuse. So if I could draw it into the original pictures, we see this is the A distance, and this is the B distance. Okay, so our hypotenuse, our label, all that we're missing is the lower edge. And the lower edge is the distance from the center out to the focus. And we don't have a value for that. So let's go back to the original picture on the left, and let's say the distance from the center to the focus will always be labeled C. In the other example, the distance from the center to the focus is labeled C. Okay, so that's our missing edge. The distance from the center to the focus is C. The distance from the center to the focus is C. So let's make a comment here. Distance from center to focus, and this is for both cases, is labeled C. Okay, I'm going to put this in the cloud because it's going to help us remember how to draw these things. The distance from the center to the focus will always be labeled C. The vertical distance of the original pictures, the vertical left and right, will always be labeled A. The horizontal distance up and down will always be labeled B. So let's write these out. Vertical distance is labeled, so that's going up and down. The vertical distance is always going to be labeled B. And the horizontal distance, left and right, in my version, not your textbook, but mine, is always going to be labeled A. If we could just remember these three rules, we'll always be labeling our right triangles correctly.